So good morning, evening to all the audience who have joined the webinar today from all across. We welcome all of you to the second part of the algo trading projects. So the main purpose of doing this session is to showcase wonderful projects not done by the faculty members, not done by the quantity experts, no one from the content team, but by the EPAT students and learners who come from various educational and professional backgrounds. Doing a live project is one of the essential steps, and I would also like to call it as an opportunity that every student in EPAT has. Project-based learning is proven to be one of the most effective ways to provide practical applications. So for efficiently completing the project, the participant in EPAT is supported with definitely from the learnings that he gets from the EPAT program. He gets a push from the support team so that they don't forget about the objectives of joining the EPAT. Mentors from the specific domain who are experts in that field. But the most important actually is the time, commitment, and passion that is shown from the students' end to complete the project. And also the choices that the student have to select any project in the quant and algo domain. So we will get started now. We have today Bala and Mark who will showcase their projects. Both are accomplished individuals from the same batch, that is batch 42. They are EPAT Certificate of Excellence holders and became alumni in October 2019. I would like to first introduce Bala. His full name is Bala Murugan Ganeshan. He is a product professional with an MBA in finance from SP Jain, BTech from NIT, Calcutta, and he completed CFA level 3. He has around 12 years of experience as business analyst, product manager with a proven track record in building products in the fintech industry. He has extensively used the latest technologies to build products such as implementing deep learning models in TensorFlow, Keras, machine learning in scikit-learn, and statistical analysis tools using Python. He is very passionate about the algorithmic trading domain to put all his skill sets to good use and complete the EPAT program. In EPAT, he was trained by world leaders in algorithmic trading and gained a solid understanding of various real-world implementation techniques in quantitative finance and high-frequency trading. Currently, he works as a feature lead with Bank of America. So now I would like to call Bala to share his project with everyone here. Bala, I will make you now the presenter.
Yeah, thanks a lot, Ajit, for that wonderful introduction. It was really good. Let me know if you can see my screen.
Yes, we can.
Okay, just okay. So welcome everyone to this presentation. Good morning, good evening from wherever you are. So the agenda for this presentation is to showcase my project work done during the EPAT course back in 2019. The motivation behind that, the thought process, the challenges faced, the results, and the next steps. Hopefully, this would motivate the listeners to explore deep learning techniques in their trading. So I have around 20 minutes. So I'll do the presentation for probably around 15 minutes, and then we can have the last 5 minutes for Q&A. Okay, so let's get started. So the project was about developing a deep learning model to predict the price of Bank Nifty index. So this is an index which is listed in the National Stock Exchange of India. So let me just get started with the motivation and approach I followed. So as Ajit said, I'm very passionate about the algo trading domain, which motivated me to join EPAT course in the first place. And I'm more of a hands-on learner and wanted to explore deep learning the practical way, as it hasn't been used much in trading as far as I've searched in the public domain. Hence, I decided to do a project on deep learning and understand how it's applied so that it might provide a good foundation for further research. And I was also sure that I'll get good support from Quant Institute as they assign a mentor specifically to you. And the person assigned to me was an expert in the field of machine learning. So it would have been really difficult for me to complete such a project on my own for sure. So that's the reason I actually picked this particular domain. And the reason I chose Bank Nifty was that it had huge volume and volatility, which is generally an ideal candidate for trading. And it also has huge interest from the intraday trading community as well. So this was my thought process and motivation to do this project. Next, let me quickly highlight the approach that I followed to build the model. So I built two deep learning models, one for predicting the index prices and another for forecasting the underlying stock prices that make up the index. So I only consider the top 5 constituents that make up the Bank Nifty index. And at the time of this project, the following are the stocks: the HDFC Bank, ICICI, Axis, Kotak, and State Bank of India. And the trading decision will be made based on the outputs of both the models. Say if both the models predict the prices are going to go up, then we take a long position. And similarly, if both the models predict the price are going to go down, then we take a short position. So that was the idea, so that we can predict the index as well as the underlying stocks that make up the index. And we only take trades on the days that both the models predict the same direction. So that was the idea for this. And I only thought of predicting the open prices because most of the movement in the index happens overnight, and it opens either gap up or gap down most of the days, with volatile moves throughout the day exploding in either direction. So I thought if we predict the open price, that will actually give you more value. So that was my approach. So next I'll talk about the data set that's used for training and the testing phases, the system setup that was used, and the model specification. So coming to data, coming to the training phase, for the index model, I used 21 months of 1 minute data. Whereas for the stocks model, I used 20 years of daily data because I was actually exploring the free data sources that were available. And it was pretty difficult to get 1 minute data for the stocks due to corporate actions. It involved a lot of cleanup activities, whereas for the index, it was automatically taken care. So that was a rationale for choosing 1 minute data for index, whereas going for a daily data in case of stocks. And for the testing phase, I used 6 months of 1 minute data for the index and 1 year of daily data for the stocks. So this is about the data. And I've also mentioned the different libraries that were used along with the versions next to that. So TensorFlow was the backend. So that's the library that I used to build the neural networks. Keras is a wrapper that's written on top of TensorFlow so that you can easily create a model with a few lines of code instead of worrying about a lot of backend details. So I chose Keras and TensorFlow was the backend. And scikit-learn was basically used here for publishing the result metrics because most of them are inbuilt within scikit-learn. And I also used the XGBoost model, which I'll touch upon in a minute to understand the feature importance of different input data. Then you have Talib. So Talib is a well-known library for your price action technical indicators. So for technical indicators, I use Talib. And then IMB Learn is it's actually a library called Imbalance Learn. So whenever you have imbalanced data, say your number of positive cases are less than negative cases or the other way around, you can use Imbalance Learn to oversample the data that is less. So it ensures that the data is balanced. And then for the backend database, I used my own MySQL database because it involves a lot of cleanup, removing a lot of null values and stuff like that. And if I have my own database, I don't have to spend a lot of my time in data cleanup activities. So that's the rationale behind having a MySQL database. Then coming to the model specifications, since this was the first time I was actually exploring deep learning, I wanted to keep it pretty simple. And you can see that both the models, the index as well as stock model, are binary classifiers. So the target was assigned 1 if it's up move and 0 if it's a down move. And coming to the feature sets for the index model, I used the open, high, low, close, and volume 1 minute data for the index. Because if you consider 1 minute data, you'll have around 360 minutes per day. And you have 5 categories here. So it's 5 into 360, and it will give you a lot of feature sets. So that's the reason I didn't go for any technical indicators for the index model. Whereas for the stock model, it's a daily data. So you have only 5 data points for your daily data points. And I also included technical indicators. So I made sure that I cover technical indicators from all the categories, like momentum, like you have RSI and ADX. Similarly, volatility, you have indicators like ATR, Bollinger Bands, and you also have volume-based indicators like money flow index and moving averages. So I considered all these, and since I had a lot of feature sets, I wanted to narrow down the ones that have more relevance. So that's the reason I used a feature called feature importance from the XGBoost model. So feature importance, it's a method in decision trees that assigns a score to input features based on how useful they are at predicting a target variable. So basically, the predicting capability of the input feature is what it gives. So I used XGBoost to plot the feature importance that's shown at the right extreme. And so if you look at that, it shows the top 10 input features and the corresponding F scores. O minus C is nothing but open minus close. So I also used a different combination of the price data, open minus close, close minus low, and so on, and only pick the top 10 items here. So this is about the system setup, model specifications. Let me next move on to the challenges and key learnings here. So this is where the Quant Institute helped me a lot, especially the mentor that was assigned to me. He was able to highlight each challenge that I might face and what will be a solution for that. So the first thing, as I highlighted in the previous slide, coming up with the relevant features. So for that I used feature importance from the XGBoost classifier. And most of my time, if you see, it was spent on data cleanup activities, scaling them to ensure that the machine doesn't assign data with a larger number more importance than a data with a smaller number, and imbalance. So the number of positive cases and the number of negative cases were not equal. They were actually like 70% were positive, only 30% was negative, something like that. So for that, I used a oversampling technique called SMART, which is called synthetic minority oversampling technique. So this is given by the IMB Learn library that I just mentioned previously. And I've also given a sample code snippet here, method defined as balance data. So you just have to supply your input features and the target variable, and just define a smart object. And once you fit the data set, it will automatically make sure that both your positive and negative cases are equal. So it's as simple as that. So I used smart for making sure the data is balanced. And then for scaling, I used standard scaler to ensure that all data is normalized and there is no preference given to large numbers. And then the biggest challenge was computational power. So I didn't have a GPU to train these models. So I had to reduce the feature set and also the training period as well. So initially I thought I'll use the complete 360-minute data for predicting each output, but then it went on for hours and hours for training. So I reduced it to just the first 1 hour and the last 1 hour, so that at least our training time will reduce. And I found that the first 1 hour and the last 1 hour has more impact to the next day's open price. So that's how I overcame the computational power. And then the biggest problem for any deep learning model is overfitting. So that's where we have callback functions within Keras, which helps you do a lot of things. And I used a couple of callback functions. One was called as early stopping, and the other one was called as model checkpoint, which is used to save the best model. So I just mentioned the code snippet below that. So if you look at the model checkpoint, you just have to give the model name and what particular metric are you monitoring. So in this particular case, I mentioned the validation accuracy. And validation accuracy because your model will start overfitting once your validation accuracy starts going down, whereas your training accuracy starts going up. So that's the point where you know that your model is overfitting. So that's the reason I mentioned that as a metric, and it will save the model. So even after thousands of iteration, you will still get the best model that was fit. And then for early stopping, you have to mention similarly a validation metric. So I mentioned validation loss and whether it's a minimum or maximum value. So since it's loss, I mentioned as minimum, and the patience level. So for how many iterations will the model wait before stopping? So here I mentioned as 200. So for 200 iterations, if the validation loss is not improving, then it will stop the training process. So that's the idea behind having callback functions. So I've just used a couple of things, but there are even more callback functions which can be used to help you create better models. So this is about the challenges that I faced. And next is the results. So these are the results for the testing phase, not the training phase. This is for testing phase for the data that was not used while training. And if you see, you can see the 5 result metrics for the stocks: State Bank, ICICI Bank, HDFC Bank, Kotak, and Axis Bank. And the one at the right bottom is the output for the index with the border. Just to differentiate, I put a border here. And in machine learning, if you see, the performance measurement is an essential task. So when it comes to a classification problem, the most recommended metric which gives a true picture is considered to be AUC, the one that I'm using here. It's called area under the ROC curve. So ROC is a probability curve that's plotted between the true positives versus false positives, and AUC represents the degree or measure of separability between the classes. So it tells you how much the model is capable of distinguishing between classes. So higher the AUC, the better the model is at predicting zeros as zeros and ones as ones. And the maximum value is 1. And if you see, we've obtained a AUC score of around 90 to 80% for the stock model. And for the index model, it's around 60%. So generally, anything above 50 to 55% is considered to be pretty good for trading. The other result metrics, I've used accuracy, which is pretty straightforward. It just give you how much percentage of the data you're predicting correctly. Then you have the confusion matrix. So confusion matrix will give comparison between the true values and the predicted values. And these diagonal values are the most important. So the top left quadrant will give you the true positives, and the bottom right quadrant will give you the true negatives. And these should be pretty high. And it's pretty high across the board. And then you have the classification report, which gives you precision, recall, and the F1 score, which is nothing but weighted harmonic mean between precision and recall. And finally, you have the AUC score. So this is the results of the model that I developed. And then going on to the next steps. So this project, it just showcases a framework to develop deep learning models. And it also shows that the deep learning model seems to be pretty effective in predicting stock prices. And coming to the data sets, I've only used price action data, but then you can also use fundamental data, sentiment data, which will definitely improve the model accuracy. And as I said, the biggest challenge was the computational power. And to fine tune your hyperparameters like number of hidden layers, the number of nodes within each hidden layer, the learning rate, the activation function, the optimizer, and so on, you'll have to do a lot of trial and error. So you'll definitely need a lot of computational power, because for each change in value, you'll have to train the entire model again and again, and which might actually go for hours. So that was another big restriction here. And if we have good computational powers, I'm sure that it will give you a lot of flexibility in terms of defining the model. And the last thing would be that the models that we define, it should be applicable in real life trading. The one that I defined, I actually took data till 3:30 p.m. So 3:30 p.m. is when the market closes. So if you take the data till 3:30 p.m., then it doesn't give you any room to take a position for the next day. So probably you can take data from start of the market till 3:15, and then you'll have 15 minutes cushion to take a position. So things like that we'll have to think at the beginning itself, so that it's really applicable practically. Yeah, so these are the things that we can actually learn from the model and take it forward. That's pretty much what I wanted to present, Ajit. We can move on to the Q&A sections.
Excellent, Bala. Thank you very much for sharing the insights. And on the chat, I have shared with everyone the link to know more about his project in detail. You can always look at it. Okay. And also, one more question that we are getting is, will the session be recorded and available? Yes, the session will be recorded and be available to everybody. Okay. It will be there on the same page where you have registered on the Contents page. Okay. All right, we'll move to the questions right now. And first question is, how good is the application of deep reinforcement learning in algorithmic trading?
Reinforcement learning is something that I have to explore. This is specifically deep learning. Reinforcement learning is more where the model learns on its own. It knows what the objective is, and whenever it's able to predict it properly, it will get a positive point, and whenever it tries to predict a negative case, it will get a negative point and stuff like that. So that's something that I'll have to explore yet. So it's not anyway relevant to this project that I've done, but yeah, it's something that I have to explore.
Okay. Didn't you try fitting regression model? I would be more interested in predicting opening price than that of up and down.
Yeah, I mean, as I said, this was my first project, and I wanted to keep things simple. And if you get into regression, then your error rate will be higher because you are actually predicting the absolute value. And if the model is way off, then your error rate will considerably increase. So if you consider it with a classifier, in that case, you just have to predict whether it's going up or down. So you just have a 50% probability. So that was a easier problem to solve, and that's the reason I actually picked classification against regression.
Okay, fantastic. For computational power, why didn't you use the Google Colab?
I used Google Colab, but the problem with Colab is if your model trains for more than 30 minutes, your session gets cut off. So then again, you'll have to do it. And there are some shortcuts where you can save the model and start from where it stopped. But yeah, that was a lot of pain. So I really couldn't use Google Colab effectively because of the 30-minute session timeout case.
Okay, okay. And what is the patience parameter? Could you just give us a little bit more explanation on that?
Yeah. For training the model, you'll mention the number of epochs. So the number of iterations that the model can run. So you'll have 1,000 or 2,000 as the number of iterations. The patience is a parameter which is considered for the callback functions. So in my particular case, if you see, that was given for early stopping. So I mentioned 200 as patience, and because of the parameter 200, the model will validate the metric that I mentioned here. So I mentioned validation loss. So it will keep evaluating validation loss after each iteration. And even after 200 iterations, if this particular metric has not improved, then it will stop the training. That's the idea behind this. So whatever you give here, that will be the number of iterations that the model will wait and see for this particular metric. And if it doesn't increase, it will stop. That's the patience metric.
Okay, okay. We have got like quite a lot of number of questions right now. We'll just pick another two right now, and maybe at the end of the session, if we have time, we will cover the other questions also. Also, you don't have to worry if any of your questions are not answered. We will have it answered for you. You can always contact us, but we will make sure that all your questions are getting answered. Uh, because of time constraints, we may not be able to do all, but we will try to complete as much as we can. Okay, we'll just pick two more now before we move ahead to the next one. How much time did it take you to complete this project?
took me around, I think I started in September mid and I completed it by October mid. Yeah, it took me around 1 month.
Okay, that's pretty fast. Do you plan to apply the model to other stocks and stock classes?
Yeah, I mean, I'm actually figuring certain things out now. But apart from that, it's actually helping me a lot in my current work environment. So I work on a regulatory product and predicting the risk metrics. Machine learning is actually playing a good role over there. And I was able to create a couple of models in my current work, which really was helpful. But for stock market, I think we need more alternative data, like your fundamental data, sentiment data, and all will definitely improve the model accuracy. And most of them, to source them, to clean them up, it takes a lot of time. So that's where I'm spending most of my time now in terms of sourcing the data. And once I have them, I think I'll explore more.
Okay, fantastic. Thank you very much again, Bala, for sharing the insights. We will definitely come to the question and answer again after, uh, if we have time. But we will ensure that all your questions are answered. Okay. We will now uh, have Mark, who will share about his project. Okay. But before he does that, something about Mark. Okay. His full name is Mark Pandel. He's an engineering fellow at a U.S. Fortune 500 company based in Houston. His focus is on complex problem solving, decision quality, and integrated planning. He holds a bachelor's degree in mechanical engineering and a master's in business administration. He has 20 plus experience of algorithmic trading experience. Mark, I will now hand over the session to you, just giving you the presenter rights.
Well, hi guys. I hope you're doing well today, and thank you, Ajit, for the introduction, and also to Quantinsti for the invitation to share the project I completed as part of the EPAT program. I just have one slide today that I'll talk to, and it will be in general in nature, and I'll address the agenda items suggested by Quantinsti, which are shown here on the slide. Before I start, though, the project I selected was to build a Python-based platform that would allow me to test the performance of different strategies on portfolios of stocks, and the data for the analysis was to be downloaded from Interactive Brokers. The objective was not to demonstrate the efficacy of any particular strategy or financial concept, rather it was to provide a framework upon which I could build into the future. So this talk is of a general nature and focuses more on the learning journey rather than offering up any money-making strategy insights. So my sincere apologies for that in advance. So starting with the first question, what was the motivation for the project? And I guess I'll take a step back. And the more appropriate question for me is and I guess for yourselves, is what motivated me to enroll in the EPAT program? I've actually been trading algorithmically now for some 20 years using TradeStation, which, by the way, is a fantastic platform. My approach is to trade various strategies on portfolios of both long and short positions to provide some diversity and also to attempt to smooth the equity curve. Now, one of the limitations, however, is that TradeStation only provides access to the US markets. Certainly if you're based in the US, you can only access US markets. So the trading of portfolios from different countries as a way to further diversify and manage the equity curve, that just isn't possible. But that said, I also had an account with Interactive Brokers for discretionary trading and was impressed by their global market access, and also noted they had the capacity for trading automation via a range of different languages. The barrier for me, and this was a big barrier, is I really had no idea whatsoever how to migrate my TradeStation strategies over to interactive brokers and then automate the execution. So the first question for me was, which programming language to use. And after quite a bit of research and reading, thankfully I landed on Python. And then given I had no experience with Python whatsoever, the second question was who could offer the best training? And again, after a little research, I located and landed on the EPAT program. And that certainly ticked the Python box. But it also offers a very, very broad curriculum, which if you're looking to trade professionally is incredibly useful. So 4 months into EPAT, my choice for a project was fairly easy, which was my starting objective: develop a platform to connect with interactive brokers using iBridgePy and test the performance of various strategies on stock portfolios, with a longer term goal of being able to code and test my TradeStation strategies and integrate them into the platform and deploy them for live trading. So that was the motivation. So in terms of the approach, for me, this was quite a daunting task. As before starting EPAT, as I mentioned, I had no previous exposure to Python, and 4 months in, the concepts were all still rather vague. So my first step was to revisit the extensive material offered as part of the EPAT course, especially as it relates to Python. Then also understand the trading strategy examples provided as part of the EPAT course, but also search out the trading strategies available online. And if you do a web search, you'll find an inordinate number of Python codes for various different strategies you can cut and paste and begin to play with. So that was the first step. And then for the purpose of this project, I used a fairly simplistic strategy to build out the platform. Firstly, daily data for a single stock was downloaded from Yahoo Finance. A buy signal was generated when the price fell below the lower Bollinger Band, and a corresponding sell signal generated when the price rose back up above the simple MA. And conversely, a short signal was generated when the price exceeded the upper BB, and a cover signal when the price fell back below the same simple MA. The daily and annual returns were then calculated, and the top right plot there shows the strategy, shows the candlestick stock prices, the Bollinger Bands, and then the lower subplot shows when the positions are just long here, when the positions are actually open. I then downloaded further data from Yahoo, set up a list of tickers to use as a portfolio of long positions, and coded a loop to generate the buy-sell signals, and then calculate the P&L for each position, and also the P&L for the overall portfolio. The next step was to connect with interactive brokers to download the stock data rather than downloading it from Yahoo. For this, I installed iBridgePy to serve as the bridge between the Python console and the interactive brokers interface. And with that installed, I then set up a paper trading account with interactive brokers, set up the required data subscriptions, and then reran the strategy to test the functionality. And I will say the EPAT lecture material from Dr. Liu, who is the author of iBridgePy, was very, very useful here. So once that was running successfully, I updated the strategy to loop through a portfolio of short positions as well as the long portfolio. And with all that running well, then prepared some simple analytics to evaluate the performance of the strategy and the portfolio, which we can see to the right here. The first row shows the cumulative P&L for the trading period for the individual stocks. The first shows the stocks within the long portfolio, the middle, the short portfolio, and the right is the long and short positions combined. The second row shows the overall cum P&L for the portfolios. Again, the first is for the long, the middle for the short, and the right for the overall portfolio. Now, a key issue with deploying strategies that trade intermittently on a portfolio of positions is to ensure your account size is neither over nor under leveraged over time. So the lower graph plots out the capital deployed for trading the long, short, and overall portfolios, and can certainly be used to set your position size for each of the stocks, so you can be compliant with whatever leverage objectives you set yourself. So what were the challenges that I faced while doing the project? I guess for me, the primary challenge was the lack of proficiency in Python. Although this project did drag me kicking and screaming up the learning curve, I found iBridgePy and interactive brokers quite fiddly at the start to get running, at least certainly relative to TradeStation, which is very robust. But once set up and once you know what you're doing, the iBridgePy and interactive brokers interface works like a dream. So how did I overcome the challenges? I guess for me, I mean, I've always been incredibly passionate about trading. And I think it takes unbridled perseverance. Certainly for me, as the learning curve, as I highlighted, was very steep, and at times immensely frustrating. The EPAT faculty were incredibly helpful when I was hitting dead ends, and also the iBridgePy have a good community as well, and have a very robust suite of online documentation, which was also key to successfully linking into the interactive brokers site. So thanks guys for your help and support. That's greatly appreciated. So what were the learnings for the project? That's a great question. For me, despite the rocky start, I've been programming extensively for the last year now. So this project gave me a very good start, and I now feel very, very confident working with Python and the various different tools within that ecosystem. So that's certainly a win for me and a very important skill that I've acquired. On a more personal note, given the challenging start, I think the journey's highlighted the importance of setting goals, staying focused, and playing the long game. And I think these were certainly very effective in helping overcome significant short-term barriers and frustrations that I went through at the start. So next steps. I guess it's been over a year now since I completed the project, and I've certainly been, as I mentioned, very, very busy and completed many of the planned post-project next steps. Initially, I focused on coding the TradeStation strategies into Python and used those to replace the Bollinger Band strategy I described for this project. Arguably, the most challenging aspect was replicating the suite of trade management features. What could be achieved in TradeStation with 50 lines of code using their inbuilt trade management functions took well north of 1,000 lines of code in Python. So that was certainly good to get that coded and working. I then built a module to send orders to the interactive brokers trading desk, then tested those using their paper trading account, which is great, by the way. And then once that was working well, the strategies were deployed live in the market, and thankfully they're continuing to perform well today. With that done, all in, it was probably well north of 1,500 lines of code just on one screen. So with that done, I began streamlining the code into functions so the primary program could be read on one screen. And certainly this was well worth the effort, as it made the code more robust, easier to manage, and then change and import and export between different strategies. I've then upgraded the code to use intraday data, and then loop through different portfolios for different time periods, and then combine the results to evaluate longer term performance. So as we begin to wrap up, building on the framework I developed as part of the project, I've now got a very powerful platform to evaluate the efficacy of different entry signals, trade management strategies, applied to different portfolios on varying time frames with extended data sets. And I'm looking back decades to test these various aspects, which of course is an invaluable part of understanding your edge and then getting comfortable with deploying before you deploy a strategy live into the marketplace. So current and near-term projects now include the integration of machine learning into the platform, the use of dynamic portfolios where the stocks available to trade are ranked real time, and varying entry and trade management signals with market conditions. So that's all I had to share really, and I think I'm getting close to out of time. So I'll wrap by again thanking Quantinsty for enabling what has been a prolific journey of learning, and for the opportunity to share my experience and the project with you today. So with that, thank you very much, and questions.
Sure, Mark. Thank you. Thank you very much for being a part of this journey with us, and a great session from your end. And thank you for sharing the learnings with us. I will now just have a couple of questions asked from the audience here. So first question would be, as an experienced trader, what type of annual returns are you able to consistently deliver over the last 5 years? The person asking is a newbie and he wonders what is realistically achievable. So I think it all depends, but I think you would be the best person to answer.
So I think that that's a great question, and that's a question that's often asked. And I think a more important question is what are your objectives? And what are the reasons, if we look at the last 5 years, if you look at the performance, at least of the US stock market, it's been on a prolific bull run. I mean, well beyond beyond norms. So if you're trying to trade short, if you've got a portfolio that's 50% short when you're trading that environment, that can be somewhat challenging. So in terms of my objective, what I try to achieve is I try to approach the performance of the S&P 500, but actually reduce the volatility, significantly reduce the drawdown that's experienced. So I think if you were to look at the returns from the S&P 500, that would be a good proxy for how I'm performing, but with significantly less drawdown.
I hope that answers your question. If there is any, you can always ask back. Would you suggest the EPAT course for those who don't have any programming background whatsoever? How much value would this course add for the person who doesn't even know the most basics of the programming language?
So I think I've had this conversation with EPAT earlier, and one thing I'd recognize is that EPAT provide a significant amount of material to allow you to become more conversant with Python in advance of starting the program. And the program is very much focused around Python. So if you can't program in Python, then I would suggest you're not going to get the full benefit from the course. I think my issue was I didn't give sufficient attention to the advanced material that was provided. So as I mentioned, the learning curve, I was dragged kicking and screaming up that learning curve. So I think if you want to get the most from the program, being semi-proficient in Python would be a great benefit, a great foundation. But if you don't, it can certainly be done, but it will be more challenging. That was my personal experience.
Thank you for sharing that, Mark. And I know you are wanting to hear from the students' perspective, but recently, Mark is from batch 42, and very recently we have started with preparatory sessions. I just want to also inform you, Mark, that we have started with Python preparatory sessions, which are before the actual orientation, even before the orientation session. Plus, we have added 4 tutorials also on for those who are not who want to have additional learning experience. You have additional Q&As. We have started with the additional tutorials which happen after the Python sessions, immediately after that particular session. So that is what we have added. But yes, that's what I wanted to just add to that. Okay.
Yeah, that's great to hear, and I think the participants will find that exceedingly helpful, at least those with no prior experience.
Right. And also these sessions are available for lifetime. And Mark, also, if you are not aware, you also get the most recent lecture recordings from the latest batch added to your alumni portal. Okay, that's also I wanted to just add one point in that also. Go to the next question now. In the context of trading, can you please drop some light on Monte Carlo simulation and Brownian motion, if you want to answer that?
I certainly use Monte Carlo simulation as part of my decision-making job and decision tree as part of my day-to-day job. But in terms of trading, I've not actually used Monte Carlo simulation, so that's probably not an area I'm probably well positioned to comment on as it relates to trading.
Okay, no problem.
Sorry about that.
No problem. What was your objective for switching from TradeStation to Interactive Brokers, and did you achieve those objectives? Which all markets do you trade or plan to trade in the future via Interactive Brokers?
So I'd mentioned it at the start of the presentation. TradeStation actually does provide an interface where you can trade TradeStation strategies and link in and execute them via Interactive Brokers. But for some reason, and it must be a regulatory, some regulatory driver, you can't actually access that capability if you're living in the US. If you're in the UK or in other locations, you can actually do that. So from my perspective, I could only, using TradeStation, I could only access the US markets. Now, one of the things I like about trading both long and short portfolios is they give you some level of diversity, and they allow you to attempt to smooth the equity curve. I'm just as an aside, I'm also a resident of the UK and Canada, and sort of invest there as well, and see myself sort of ultimately living in those locations. So the FX is also an important risk to me, is being overly exposed to the US dollar. So being able to sort of have portfolios of, let's say, Australian, European, Indian, UK stocks, having portfolios set up to trade those, give me, because they are correlated with the US markets, but less so than within the stocks within the US portfolios. So that gives me additional opportunity to diversify, and it also removes some of the currency risk as well. So that really was the driver behind moving away from or sort of creating an adjunct to TradeStation, where I could sort of expand the portfolios and mitigate some of the FX risk. I'll carry on using TradeStation because it's a fantastic tool, but Interactive Brokers gives me that more global reach.
Okay. Thanks very much for sharing. So the two of the audiences, two of the people from the audiences have appreciated for wonderful presentation and mentioned good things here. So thank you very much, Bala and Mark. And just last two questions we will take, and then we will wrap up. Uh, how long did it take you to migrate from TradeStation to an operational framework? And what recommendations would you give to someone who wants to do the same?
To do the project and set up the framework, similar to Bala, didn't take much more than a month. As I mentioned, it depends on how you trade and what you want to code. My trade management rules are fairly complex. They use staged exits, trailing stops, maybe market regime change switches. So as I mentioned in TradeStation, there's functions that you can use to trade that or to sort of set that up, which is quite nice. Within Python, it becomes a lot more complex. And as I said, I found that replicating the TradeStation code took around 1,000 to replicate the TradeStation trade management rules took about 1,000 lines of code. And again, it was during the period where I was gaining proficiency with Python, so I was hitting a lot of dead ends. But it probably took me about 4 months to get it working. But I also looked upon that as an opportunity to learn as well and expand my coding capability. But that was a fairly sophisticated suite of trade management rules that, as I say, took 1,000 lines of code. If you were looking at just sort of similar to what I presented, the Bollinger Band strategy, that would be very easy to code and probably wouldn't take many lines of code at all. So
great. That's good. Thank you very much. All right. Can we take one more question, Mark?
yes, absolutely.
Yeah. What resources did you use to overcome the barrier of Python?
I certainly the EPAT material is very relevant. So the fact that they offer up trading strategies that you can sort of take, and they give you the code for those trading strategies, you can take those and then play with them and adjust them, get familiar with them. That's a great resource. It certainly didn't address all the trade management issues that I was facing. So that requires reaching out onto the internet. And one of the things I think once you face sort of barrier after barrier, one thing you find is that the internet can pretty much answer any question that you actually have and offer you the coding solution for any question you may have. So Stack Overflow, general internet, sort of Python sites should be able to, offer, be able to sort of provide guidance and resolution to any of the issues that you find. Now, one of the things I do find is that, and maybe it's a version control or other issue, but you tend to have to maybe try three or four solutions before you get something that works. But certainly I found the internet invaluable when it comes to when you hit a barrier, finding out how to just cut and paste the error message into your browser, and that will send you in the right direction.
Right, absolutely. Internet is an absolutely amazing resource, and you get all your queries, everything. Any other question also you have, you just put it on, and you get the answer. I just want to add one more thing, is that we, the faculty or the content team at Quantinsty, have also has written a book on. It's available online on Python for trading, which you can freely download to understand what are the basic requirements for knowing Python for trading. So it's not a book to learn Python language, but important aspects and important library packages, functions that you would be using in trading. Okay, so that book is also available freely. Just adding to that answer of yours. Well, thank you very much, Mark and Bala, for such a wonderful session today. We really appreciate you coming forward and taking the time out for the session for us and for the listeners. I'm sure all of you must have benefited a lot here. For more information on the projects, you can always go to our website, uh, blogs.quantity.com/tag EPAT trading projects. Okay, you will be able to see numerous projects on our website. If you want to take inspiration from them, you can definitely do that. There's another great place where you can look out if you want to look out for people who are like you. For example, you are a doctor and you want to come into trading. You are into government services, you want to come into trading. You are in college and you want to come into trading. All of these success stories are available with us. You may be it would quite be relational to what you are doing currently. If you have any queries, any questions that still remain unanswered, you want to ask, you can reach out to contact@quantensty.com, and we'll be happy to provide you any answer, any resolution, any solution for your query. Okay. Special thanks to the Mark and again special thanks to Mark and Bala for coming forward and taking this session. It was really wonderful to take the session. Listen, there were some very great questions that were asked. Thank you very much for joining in, everyone, and have a great day ahead. Thank you. Bye bye.